Hi, this Papa is new, and we are back for one more episode of 7 billion humans. Okay, so what happened is I'm really bad at optimizing all this so-called programs. Okay, parallel program. All right, they're pretty high level, and then sometimes it's really hard to figure out the exact so-called thing that can help us make this thing faster, okay, especially since it isn't like a well-documented language and so on. Okay, we'll take a look. Right, so I take it offline and try it out myself, see how long it takes. Interestingly, it doesn't take as long as I thought it will for at least this first few levels. Okay, and that resulted in some horrendous code. So I thought I should actually share a little bit on why usually actually we don't do it, okay, this kind of optimization, and why it's actually hard. Alright, so without further ado, let's check out level year 6, okay, Little Exterminator. Right, so the job is to move all the way to the end, okay, and pick up the cube, okay, at the end. Right, so previously I had the speed challenge. Okay, speed challenge is straightforward. The way to receive speed challenge is to hard code the whole thing. For parallel programming, you seldom have that kind of situation. Okay, we'll look at another example later. Okay, so we usually don't do that because then this code cannot be used elsewhere. It can only be used exactly for that situation, whatever that we hard coded. Alright, so there's another problem, which is the size challenge. I couldn't hit 9. Okay, it hovers above, I think, 11 or something. Okay, so the technique which I discovered later is that actually if loop itself can be overloaded, and the if condition just take one command. Okay, this is command 3, command 4 is step. Okay, so this all and everything, this counted as one command, and this is exactly what I need, because what we derived the last time is that, well, I need a way to step down and a condition for it. So that's 2 steps. I need a condition to step left, a condition to step right. So each of them is 2 commands. Okay, that's 6 command already. I need 1 to loop the jump, to loop, and that's 7 command. And then the pickup itself, at least 1 pickup, that's 8. By right, I should if the pickup. Okay, check whether it's a data queue and pick it up. This is actually slow, apparently. So in this game, if we do something that is so-called invalid, okay, the character will complain. We'll see the character complain a lot later. Okay, that will slow down actually the program. It takes more steps to complain, but we are not chasing for speed, we're chasing for size. Okay, and this work. Alright, and this is a hack. Okay, this is a hack. What I'm doing here is this: if the bottom is not a hole, step down. Pretty good. Where do we want to step down? Here. Okay, bottom is not a hole, good, step down. Bottom is not a hole, good, step down. Same for here, bottom not a hole, step down, step down, step down, step down, step down. These are the places we want the character to step down, okay, and it is a very simple command. Bottom is not a hole, just step down. Alright, so the few things that one place I need to turn left is here, the other place I need to turn right is here. Okay, and they must be such that if there's opportunity to step down, it should not move away. Alright, so we need a condition to say that, you know, if bottom itself is a hole, then this thing trigger. If it doesn't, then it shouldn't trigger. Okay, and that's the problem with this language, because usually in programming it's very important to have precedence. The usual precedent is that n will apply before or, and n is something like multiplication, or is something like addition. It's really hard to explain this until you really see examples of it. Okay, but then just like usual operation, you multiply first before you add, right? So same thing, you end first before you or. Alright, that's without bracket, but we usually always put bracket most of the time. I think personally I put it most of the time because it's still pretty ambiguous on first sight. Alright, this is hard. There's no bracketing, and the rule is really very weird. Okay, the rule is really very weird. I don't know how to explain, but this ordering actually work. What it means is that the first one apply, or the second one apply, then this is currently still true, but I need to check to make sure the third always apply, because third is the end. Same thing here, or end means this one has to always be true, and then any one of this is true will be good. pretty weird ordering. Okay, it is. I don't exactly figure out how it works. Okay, there's just some hunch. Okay, and this thing when I created it worked. So what happened is then we can start the process. Is it down? Then it's good. Okay, if it's not, you don't care. And then it will always prompt a pickup. Okay, nothing will pick up. Hey, yeah. So that wasted some time, right? Okay, observe that you actually stuck there for a while. This move, you actually stuck there for a while the complaint goes on. Alright, so it slowed down the code. But this worked because of the condition that we are setting it up. Okay, let's pause this. Alright, this condition is really weird. We check whether the left is a hole. If the left is a hole, I should move left, correct? Nowhere else would that happen here. The other thing I'm going to check is if the diagonal place is not a hole. So when I'm standing here, this is not a hole. So this condition won't trigger, but I want it to trigger to step left. So the way I do it is to check whether the diagonal one is actually a platform. Okay, none of these four squares have that property that the diagonal left is a platform. So that allows me to step left. It's totally hackish. This is when programmers always tell you that they hack their program and you don't really understand why. This is what an example of hack. It has no meaning towards the answer. It just works because we make use of some very strange property that's only true for this case. Okay, that is hacked. Alright, so same thing. This set of condition only works for these 4 squares and doesn't work for these 3 squares. Sorry, actually these 2 squares. It works for these 3 squares, but not these 2 squares. Alright, so this 3 platform, let's check it out. What we want is, of course, the bottom is basically a hole. Okay, if it's not, it should move down, correct? And therefore it should wait there. Then the thing is check is, if left is a hole, this satisfy, right? Okay, if left is a hole, if the top left is a hole, and then if the top left is not a hole, or if the bottom left is not a hole. So if I stand here, the top left is a platform, good, you'll move right. If I stand here, the bottom right is a platform, good, you'll move right. It is not true for here. Observe that these 2 are holes. It's not true for here also, these 2 are hole. Madness. This kind of hack is madness. But it works, okay, it works, and it keeps complaining along the way. It allows me to reach my 8 steps. 8 steps is the minimum, okay, the global minimum that people has found in this game. Or maybe you have a more beautiful solution than mine. Alright, I'm not exactly good at it, but wow. We don't do that in real life, correct? This is really for street cred. Like, yay, I can get this done, you know, in 8 steps, yay. Please don't do that in real life. No one like to watch this kind of code, you know, no one like to read that. Okay, 7, collation station. This one is the same thing, okay? I had 2 loops. I think this one, okay? I had 2 loops, and this is usually how we setting up because there's 2 processes. One is to pick out the data cube, correct? One is to put it exactly before the hole, alright? And then we just stay there. We just stay there. No one get killed in the process. This is actually efficient. This is a balance, okay, between speed, efficiency, okay, the code you read, the code is well structured. This is usually how we write in real life, okay. So speed is good, 6 seconds, okay, average. Code size double, wow, like how to save half of it? Well, to save half of it, we need to delete half of it, right? Okay, so this is a size challenge. How we do it, we always step down. We always attempt to pick things up. This will complain. It is bad, okay? In programming, we always handle our exception because when program complains and we didn't handle them, that means we didn't cater for them. Something else might go wrong down the chain, and that's bad, okay? It's not well taught, and then things may fail in a bad way. Okay, so this is bad, but okay, fine. In that case, we save the check for the pickup, alright? And then if the bottom is a hole, I just drop. Alright, so I keep trying to pick things up even if I can't, alright? Or even if I am holding on to something, they'll keep complaining, that's okay. When I reach here, it will drop it down, and then it will continue all the way the step, and then all the employers, they will just fall into the hole there. Wow! So you can actually get it done in 5 steps by killing everyone. Not really the right thing to do, okay? There are also some situations in real life programming, we are wasting resource because we don't so-called put a stop to them in code. Alright, that is bad. Okay, so we don't do that. This one is really to chase the optimization challenge, but in this aren't the kind of optimization we will do. Okay, usually we don't do it to this extreme because the price to pay is too much. Okay, due to that. Okay, which else? I think 10 and 12 I didn't have. 10 and 12 I didn't have. Okay, let's look at 10. Emergency escape. This one very straightforward. Okay, so size itself. Did I hit size the last time? I might have hit size, I think. Okay, so size is pretty straightforward if we know that the if condition can be compiled together into one, right? Okay, so in that case, this exactly hit 9 steps because once again there is 4 directions to move. Each of them is conditioned, so there's two commands. Okay, 8 commands already, and you need repetition, and that's the 9th command. Alright, I think that's the minimum we can go. And someone did 7 commands. Wow, madness. Then more hack need to be done. I'm not sure whether I want to get there. The likely not. Let's not go there. Alright, let's not go there. Alright, so the speed challenge, to hit the speed challenge, very straightforward, is to... Okay, it's very low. My initial run for this is very high, right? So the idea is hard code, correct? Hard coding works as long as you can put every input into the same situation. That isn't the case. Everyone is standing so far apart. So the technique here is to move everyone to the exact same location. Okay, break it up into 2 parts. Okay, two procedure. The first procedure is to move everyone to the same location. So what I'm going to do is to move everyone up first and then left. The real start is this data cube. Okay, so the first part also have 2 parts. One is to move everyone up, okay, flush with the hole, okay, platform below the hole, and then move left all the way until we reach the data cube. Let's check it out. Okay, the top is not a hole, we step up, correct? Otherwise we are done. Alright, we are done, and then we will step left. We'll step left until we reach a data cube. So this is the 2-part process, okay, of the first procedure. Okay, then everyone will reach here. After that, we hard code. This is a hard code. If everyone is starting point by here, right, by step command 6, okay, everyone is here. Then I just ask everyone to move accordingly, and hard coding allows another level of optimization. Not originally, the only way to traverse is to move through the whole data cube line. But since we're hard coding, right, we can make use of all these shortcuts. Okay, move down, left. Okay, go through all of this. When we reach here, just cut all the way to the top and drop into the hole. Wow, madness. Okay, we are here. Step down, step left, step down, step left, step down, step down. Okay, this is exactly what I'm going to do. Let's take a look. Everyone will try to move up and reach that data cube and finally start the procedure to move through. Okay, and then everyone will drop down that hole. Done. Crazy, madness. We don't really do that in real life unless you have this kind of situation where things are really fixed. We should make use of them. We should make use of that. We can make use of them if they really save us a lot of effort. For this case, yes, it saves us enough effort for us to try to make use of it. Okay, but this kind of condition is really rare, and whenever we make this kind of decision, we will lock ourselves out of generalized, easier to understand code. Well, frankly, you look at this, this whole string of things, you have no idea what I'm doing unless you run the code yourself. Okay, crazy stuff. Sure, and okay, so we managed to complete it in average 20 seconds. Alright, so lastly, I'll talk about unzip. Unzip is really fast. I actually managed to get the optimization really fast. I think I get both of them. Okay, so the speed challenge was slow. but I made actually a very simple mistake. Okay, so I went offline. The first thing is I tried this level. I was like, it cannot be so big a difference. And then I only make two simple change, which is this. Okay, originally I'm checking for data queue. What happened is the data queue need to be dropped before you can see a data queue. So in this case, right, observe that the dropping happened on the second steps. Okay, dropping happened on the second step. So I want to check when will this person find the data queue. Okay, so observe that, well, we step through. Okay, drop. This person, not yet, right? Okay, now the person should see that there is a data queue. It actually doesn't. It actually doesn't, because the queue is still holding on, being held on by Evelyn. Okay, so Alan doesn't seize the data queue, and then it actually doesn't trigger. It doesn't trigger. You'll move on back to the next step and thus wasting time. What it can check is the only way for this so-called this construct to happen is if Evelyn is going to drop the data queue below. So Alan can immediately know and move up. Okay, by now Alan should move up, but it doesn't. Okay, we take one more step. Alan doesn't see a data queue, so it wasted time. Okay, for this to happen. And then we'll continue, and then they will unzip. But because of that extra loop, right, it totally bloats the time to 18 seconds. It looks like I'm doing a very inefficient coding. I need to do a lot of changes to improve it to 7. But actually all I need to do is to check for worker. Let's check out how this will look like now. We are still at Alan. Let's see how Alan will react to what Evelyn is doing. Alright, so now Evelyn has already moved earlier because she actually sees the person there and moved down. Correct? And then by now, Alan is ready to move out. Okay? And then where this Janet is, Janet already sees Alan there and is therefore ready to move down. That is seriously efficient. Play through the whole thing. Same number of steps, okay, command, but the speed hits 7 seconds. Crazy stuff. Okay, so moral of the story is I'll likely not try to do all this optimization live. Okay, main reason there are a few. Correct. One is a bit esoteric, I guess. It's hard to figure out. Okay, every situation is really different. Okay, and different methods can get us there. Secondly is mostly some sort of very ugly hack. Okay, that not really sure whether it will be fun to show so-called the process. Okay, I can show you the result. I think it's pretty interesting. I actually had something to talk about the result and it takes up this video, but I shouldn't be sharing about the process, okay, of coming up with them. It's pretty painful and we usually don't do it in real life. Okay, so well, going ahead, I might go back and try some of the optimization if I find it interesting for myself. Okay, and then if I manage to make progress, I will share them. But otherwise, I think I'm just going to move on as long as I can solve. This is crazy. Alright, so well, if you enjoy this video, okay, comment below, tell me how it goes for you for this kind of optimization video, okay, demonstration of results. Okay, do like the video nevertheless, okay, so more people can see them. Okay, and subscribe to my channel to join me on more gaming fun in this game called 7 Billion Humans. So Papa is done. Enjoy.